Okay, 6.2 one-to-one functions. It's getting late, almost midnight. Let's see how I do here. All right, if f is a one-to-one function, then and f of 5 equals 3, then f inverse of 3 equals what? So if the function f takes the number 5 and spits out 3, then when the inverse function takes in 3, it should spit back 5. Pretty sure you're okay with that. Okay, if f inverse denotes the inverse of a function f, then the graphs of f and f inverse are symmetric with respect to what line? And that's the identity. That's the function y equals x. Okay, decide whether the following is true or false. If f and g are inverse functions, the domain of f is the same as the range of g. This is true. So if we look at a picture of this, if this is a function that goes from here to here, we call that f, then this is the domain of f. And this over here is the range of f. But if g is the inverse, it goes backwards, right? It goes like that. So the things that go into g are actually the range of f, and the output of g is the domain of f. So this is saying if f and g are inverse functions, then the domain of f, that's this, is the same as the range of g. So it's the same as the output of g, and that is true. Okay, so I'll move on to the next question. Consider the functions f of x equals x cubed minus 2 and g of x equals the cube root of x plus 2. Find f of g of x, find g of f of x, determine whether they are inverse functions. So what we're going to do here is, first we're going to find what f of g of x is. So we're going to take the f function, we're going to plug in the g function into it. And that means we're going to take this expression and plug it in right here to this x. So we're going to get the cube root x plus 2, but we're going to cube that and then subtract 2. And when you cube a cube root, it goes away. We're left with x plus 2, and we still have minus 2, and that just gives us x. Okay, so that means when we do the composition of these two functions, it spits out x. So we're halfway there. Now we need to try it the other way. What happens when you do g and you put f inside? So here you take g, inside of it you put the f function, and then this expression goes in right here into g. So we're going to have the cube root of that expression, x cubed minus 2, and then plus 2. So if you do minus 2 plus 2, those go away, you just get cube root of x cubed, and the cube root of x cubed just cancels out and you just get x. So that means that when you do g of f of x, you also get x. And this is what it means to be inverses. You do composition of the two functions one direction, you get x, in the other direction, you also get x. So let's put these answers in here. When you do f of g of x, you get x. And any values that need to be excluded. So yeah, there's no domain restrictions on these. You can take the cube root of any number, so we should have no problems with domain. G of f of x is also x, so that was this side over here. There are no domain restrictions there either. My guess is we're going to have a problem here soon where we have a domain restriction. Are they inverses? Yes. Okay, next question. All right, so same sort of thing. Let's try this. This is going to be a little harder. All right, so let's start with f of g of x. Okay, so we're going to take the f function. We're going to plug in g. G is 3x minus 4 over 2 minus x. And we need to keep in mind here, we cannot plug in 2 here, else we'll have division by 0. So x cannot be 2. Now we take this function g and we plug it into that x and that x. This is weird. We never did this in class. So we're going to have 2 times 3x minus 4 over 2 minus x. And all of that plus 4. Then over, now we're going to plug that same thing in for this x, which is going to be 3x minus 4 over 2 minus x plus 3. Okay, this is nasty looking. All right, so here's what I'm going to do. I'm going to distribute this 2 through. This is like a 2 over 1. So the 2 is just going to hit the top of that. And I will get, let's see, 6x minus 8 over 2 minus x plus 4, and then over 3x minus 4 over 2 minus x plus 3. And then now here comes the weird part. Because I have a fraction here with 2 minus x in the bottom here and a 2 minus x in the bottom here, what I'm going to do is I'm going to multiply this whole top by 2 minus x, the bottom by 2 minus x. Now let's see what happens. We have to multiply it through to here and here. And on the bottom we do the same thing. We multiply it to here and here. So let's see what happens. When I do 2 minus x over to here, it cancels with this 2 minus x, and all I'll be left with is the numerator, 6x minus 8. Then I'll have a plus sign, and then I'll do 2 minus x times the 4. So the 4 is going to hit the 2 and become an 8. The 4 is going to hit the negative x and become a negative 4x. And that's all over. Now same thing here. When the 2 minus x hits this, it cancels, and I'm left with 3x minus 4. And when I do this times 3, the 3 hits the 2, becomes a positive 6. And the 3 hits the negative x, becomes negative 3x. Okay, collect like terms on top. The 8's cancel. I'm left with just 2x on top. On the bottom, what do we get here? The 3x's cancel, and then negative 4 plus 6, that gives me 2. The 2's cancel, and I just get x. Okay, so when we do this, we should just get x. And we do have a domain restriction that x cannot be 2. All right, now we need to do the other way, g of f of x. So we're going to do g with f of x plugged in. So that's g, and then when I do f of x, I've got 2x plus 4 over x plus 3. And now I'm going to take all of that and plug it into g, so it's going to go here and here. So I'm going to have 3, 2x plus 4 over x plus 3 minus 4 over, and then I have 2 minus, and then this thing right here. So 2x plus 4 over x plus 3. All right. I'm going to go ahead and take this 3 and distribute it through the top here. It's going to become 6x plus 12. And I think I'm just going to save myself some time and do that. 6x plus 12 here. And same thing, I have an x plus 3 here, x plus 3 here. So I'm going to decide to multiply the top by x plus 3, and then the bottom by x plus 3. It's going to distribute here, and then here and here. So when I go here to here, just left with the numerator. When I go here to here, be careful. The negative 4 hits that, becomes minus 4x. The negative 4 hits the 3 and becomes minus 12. And then over, okay. Here we go here to here. So the 2 hits the x, becomes 2x. 2 hits the 3, becomes plus 6. And then when I do this one to this one, the x plus 3's cancel, and I'm left with, now be real careful here, when these cancel, I'm left with 2x plus 4, but I'm subtracting it. So it's going to become minus 2x minus 4, because it has to subtract both terms. And now clean up. 12's go away. I get 6x minus 4x, that's 2x. And then here the 2x's go away, and 6 minus 4 is 2. 2's cancel, we get x. Oh, I forgot to mention, here, x can't be negative 3, or else we have division by 0. So we have a domain restriction there. So when we do g of f of x, we get x. X cannot be negative 3. And these are inverse functions. All right. All right, the function x squared minus 4 with x being greater than 0 is 1 to 1. Find the inverse of f and check the answer. Find the domain and the range of f and f inverse. Graph f and f inverse on the same coordinate axis. All right, again, not a lot like what we did in class, but I think we can handle it. So x squared minus 4, x is greater than or equal to 0. So first of all, let's find the inverse. So first I switch the f of x to y. Then everywhere I see a y, I put x. Everywhere I see x, I put y. Now I solve for y, so I'm going to add 4 to both sides. And now I'm going to take the square root on both sides. So when I take the square root, I do plus or minus. X plus 4 equals square root of the right side is y. Now the y value, right, this can only be positive because we're saying that x can always only be positive. The outputs of this function can only be, or the x can only be positive. So we're only going to take the positive square root here. And that should be my inverse function. My inverse function should be the square root of x plus 4. All right, let's try that. Square root x plus 4. All right, now we want to find the domain of f. Okay, so domain of f, it says here, here's f, x has to be greater than or equal to 0. So we know that because that's given to us. Oops. Okay, so find the range of f. I think the range of f, what would be easiest is if we take this and we just graph it real quick. That's a parabola that opens up, but the -4 means it's moved down 4. And now it goes like that. So if you look at this, the domain is all real numbers, because, or sorry, we only want x greater than 0. I apologize. So we only want the right half of this. That way it's 1 to 1. So the domain is all x is greater than or equal to 0. The range goes from -4 up forever. So the range should be all y values greater than or equal to -4. So I want you to kind of think about it this way. If we draw what f is doing, f takes all numbers greater than or equal to 0, spits out values y that are greater than or equal to -4. So now it's asking, what's the domain of f inverse? Well, remember, if f inverse goes backwards, then the domain is this stuff that's getting plugged in. Now, we'll switch it to x's because when you plug these in, these will become the x's that go into here. So we're going to say for this that x, the domain for the inverse, is all x values greater than or equal to -4. Hope that makes sense. And then the range of f inverse is this side. These are the things that come out. And now these become the y values, right? Because these are the y's that come out of the f inverse. So that means that our y values must be the same as this, which is greater than or equal to 0. And I think now they want the graph, right? So I already have the graph up here. I'm not going to be able to move that. Okay, I'll just clear it. So which one is this? I think it looks like this one here. Come on, you can do it. Yeah, so this blue one is f. It looks like that parabola that's been moved down 4, and we're only looking at the right side. And then you can see that this should look like the f inverse because it should look like f inverse because it looks like a reflection over this diagonal. See if there's any others that look that way. Well, it can't be this one because those aren't even, this right here doesn't have an inverse, this blue one, because it fails the horizontal line test, so it's not 1 to 1. This isn't 1 to 1, so let's just see why this one's not it. This is not it because this is the left side of the parabola, not the right side of the parabola. So we can't use that one. So it's got to be D. All right. The function f of x equals 4x plus 7 over 3x minus 4 is 1 to 1. Find its inverse and check your answer. I don't think I'm going to check the answer. I'm just going to find the inverse, and then I'm going to find the domain and range. All right, so here we go. So we're starting off with y equals, I'm going to say this is our original function. And to find the inverse, everywhere I see a y, I put x. Everywhere I see an x, I put y. Okay, now we need to solve for y. So what I'll do first is I will multiply both sides by 3y minus 4 to clear the fraction. That'll clear here, and I'll be left with 4y plus 7. Over here, I'll distribute the x through, so I'll get 3 times x times y minus 4x. And now what I'm trying to do is solve for y here. So I'm going to get everything that has y on one side of the equation. Everything that does not have y goes to the other side. That way I can factor a y out of the left side. And then I can divide through by 3x minus 4. Okay, that should be the inverse function. So now let's just go back up here and check the original function, right? This was the original function f of x, has a domain problem. This 3x minus 4 can't be 0, right? Or else we have division by 0. So that means 3x cannot be equal to 4 if we add 4 to both sides. And that means that 3x cannot be 4/3. So we know that when it comes to the domain of f, x can't be 4/3. Now, on the other hand, when we look at the inverse function, we would have a problem if that's 0. So 3x minus 4 cannot be 0 here. And you can see that if we solve that equation, it's the exact same thing. Oh, wow. You know what I just realized? Kind of cool. This is an interesting function. The inverse is the same function, right? 4x plus 7 over 3x minus 4. This seems strange. Let's see. It's, let's see, a fraction. So let me put the fraction in there. It is 4x plus 7 over 3x minus 4. Okay. Now, domain. Find the domain of f. So here's f, everything except, hold on. Oh, here we go. Cannot be equal to. I was looking for the cannot be equal to 4/3. So it cannot be 4/3. Okay, find the range of f. Okay, well, the range of f is the same as the domain of the inverse. Okay, I drew that in the last example with the picture. Whatever the range of f is, whatever the outputs of this is also the domain of this one. So the domain of this one's everything except 4/3 again. So everything except 4/3. All right, am I done? Oh, no. Okay, now find the domain of f inverse. Okay, so the domain of f inverse, right, is the range of f. It's the same answer. That was almost confusing. Find the range of f inverse. Okay, maybe I just draw a picture because I think this is getting confusing. Okay, f goes like this. F inverse goes like this. Whatever the domain of f is, comes out over here as the range of f. But this is also the domain of f inverse, and this becomes the range of f inverse. Okay, so here, if we want the range of f inverse, that's this. It's the same as the domain of f, and the domain of f was everything but that. So because this is the same function, it's a little confusing because it's the same thing every time, but not every problem would necessarily be like that. Are we finally done? Yeah, we're finally done. Okay, good. All right, use the given graph of f of x to evaluate the following. All right, so they want to know, first of all, what's f of -5? So f is this blue function. If I go to -5, 1, 2, 3, 4, 5, at -5, it spits out -5. Okay, let me just write that down. So f of -5 should be equal to -5. All right, next problem was what's f of 4? F of 4, so if I go to 4, 1, 2, 3, 4, go up, it spits out 5. Okay, then it wants to know what is f inverse of 0 equals what, right? So what they really mean here is, I guess the way you can look at it is, this is what goes into f, this is what comes out of f. This is what would go into f inverse, and this is what comes out. So what we're trying to see is, this is saying where, this right here is saying where on the original function f is the y value 0. So look at this, where on this blue function is the y value 0, and that happens right here. And that's the point -3, 0. So that means that 0 goes to -3 through the inverse function. And then the last one is, what is f inverse of -5? And so again, this is saying where on the original function is the y value -5, and that happens here. And so the corresponding x value to that is -5. All right, that should be enough for me to go ahead and answer these. So -5. Next one, 4 is 5. 0 is -3. 5. We're done with that. All right, find the inverse of the linear function f of x equals mx plus b, where m is not 0. So even though this looks a little weird, they're saying, look, if we have a general line, mx plus b, find the inverse. So the technique to find the inverse is to switch. Everywhere we see y, we put x. Everywhere we see x, we put y. And then solve for y. So I subtract b from both sides, and then divide by m. And that's what y would be, which means that's what the inverse would be. So our inverse would be the fraction x minus b over m. Is that all? That was it? All right, this one is tricky too. Well, this one's just weird. Okay, so if f of x is ax plus b over cx plus d, find the inverse. If c is not 0, under what conditions on a, b, and c and d is f equal to f inverse? All right, so, all right, let's start this out by just writing y equals ax plus b over cx plus d. Now we switch. Everywhere we see a y, we put x. Everywhere we see an x, we put y. And now I'm going to clear the fraction, multiply by cy plus d on the left, cy plus d on the right, cancel, cancel. On the left, we get cxy plus, let's say, dx equals ay plus b. Let's move all the y's to one side, and everything that does not have y goes to the other side. Factor a y out, and then divide both sides by cx minus a. All right, so there's our inverse function. Let's go ahead and type that in, see what we get here. It's a fraction. It's b minus dx over cx minus a. Hopefully it'll take it like that. Yes, okay. Now, it says if c is not 0, okay, so assume that this c is not 0, all right? Under what conditions on A, B, and C, and D is f equal to f inverse? So they're saying, when are these two equal to one another, right? So what would it take to make those exactly the same? So let's set them equal to each other. Let's ask ourselves, what would it take to make them equal? And they're also saying, assume that c is not 0. So for these two to be equal, what would we need? What would we, I'm trying to see if there's something obvious. I don't see something obvious right away. Let's see, they both have cx down here, right? And let's see, yeah, I don't think that there's an easy way to do that. Yeah, so what we're going to do is we're going to clear the fractions. We're going to cross multiply here, and multiply like that. So we get ax plus b times cx minus a must equal b minus dx, and then cx plus d. Okay, now we FOIL. So here to here, we get a cx squared minus, now here to here, we get minus a squared x. And then here to here, we get plus b cx. Okay, that must equal, okay, here we get, boom, we get bcx. Here to here, we get plus bd. Here to here, we get, let's see, negative cdx squared. And then the last one, we get negative d squared x. All right, so looking at this, the first thing that I see is that both sides of the equation have bcx, so I can subtract that on both sides. Do they have anything else in common? I don't see anything else in common. So let's do this. Let me just write what we have. We have a cx squared minus a squared x. That has to equal negative cdx squared minus d squared x plus bd. Yeah. Okay, so let's take a look at this. This is a tricky problem. I like it. I'm running out of room. Go to black here. So look at this. This is x squared term. This is x squared term. In order for this equation to be true, the two numbers in front here, the number in front here must match the number in front here. Okay, they both have a c, so that matches. But for them to match now, I would need the a to be equal to the negative d. And then that would mean the coefficient on x squared matches. So I would need a to be equal to negative d for those to be equal. Now, similarly, if we look at the x term right here and the x term over here, I would need that the number in front of x here, negative a squared, would have to be equal to negative d squared. So I would need that negative a squared must be equal to negative d squared. And then the last thing I need is that this right here, which doesn't have any x's, would have to match with this over here, whatever's on the left that doesn't have any x's, but there is nothing on the left that has no x's. So I can imagine it's like a 0 that has no x's on it, right? That has to match that. So I would need that b times d equals 0. But that equation right there means that either b is 0 or d is 0, right? The only way you can multiply two numbers to get zeros if one of them is 0. So let's just say here, for example, b is 0. If b is 0, right, then we would have that d could be any number, and a would have to be negative d. So we'd have this, b is 0, and then a would be that. C could be anything that we want it to be. Okay, that's one thing. If d is 0, d is 0. So we have one case here. If b is 0, then we would have that a must equal negative d. And also that c is kind of free. It can be anything we want it to be. Now that's one case. Now, what if d is 0? Well, if d is 0, well, because of this equation, that would mean that a would have to be 0. And then b could be anything. And c could be anything. I have no idea how they want us to do this. Let me clear, I need to clear all this crap out of here. So I can't even see the problem anymore. Maybe I can scroll, no. A is negative d. let's go with that. That was one of our things there. Yeah, I won't ask you a problem like that. That's a weird problem, but we'll just stick with it. All right, that was everything. The first 9 problems are things you should worry about. That last one was just me at 12:30 in the morning, just messing with this weird problem that was presented to us. All right, that's it.